Next, we want to find how to deal with body forces. And body forces are like gravity, gravitational acceleration. And when I'm looking at a triangular element, we are working in the XY plane. The body forces may be expressed by uppercase X, and this is a 2x1 where I have an XB and YB. So our goal here is to find equivalent nodal forces as a result of body forces. By the way, these are usually given as force per L cubed. Correct.
So how do you differentiate this X and that of the one you took? Is it the same X you took the magnitude? 92A.
No, these are ordinates.
Okay.
So in order to find the equivalent nodal forces, FB, we are going to use shape functions. We're going to use shape functions. So I'm going to take the transpose of the shape function that we already derived, multiply it by X, and take the triple integer. So this is if I'm looking at the differential volume, we are going to take the triple integer over the volume. Remember that N is a linear function of X and Y. If I show a triangular element, I, J, and M, I am going to pick the centroid of that triangle to become the origin of my coordinates. And this is not going to affect the general case, but it's just going to simplify the integration. So just a quick note here, the integrand is simplified if the origin of the coordinates is at the centroid of the element. So what happens if the origin of the coordinates is at the centroid? That would mean if the double integer of x dA is 0. And similarly, the double integer of y dA is 0. Actually, these are the equations we use to find the origin of any area. We learned it in statics. If the double integer of x dA is 0, then the double integer of beta I x dA must also be equal to the double integer of gamma I y dA equal to 0. We were just looking here at beta I and gamma I. So beta I is equal to yj minus ym. And gamma I was xm minus xj. Alpha I is equal to alpha j is equal to alpha m is equal to 2/3 the area of the element. And F BI, so the equivalent forces at node I are equal to XB YB multiplied by 2/3a from this integral here.
Capital X.
Correct, correct. So likewise, we can expand to the J and M, and we can write the FB, the equivalent nodal forces for these body forces, which are, is going to be a 6/1. I'm going to have the FBI FBIX, FBIY, FBJX, FBJY, FBMX, and FBMY. These are all going to be equal to A T divided by 3. I didn't put the T here, I'm sorry. This is T times A, or AT divided by 3 multiplied by XB, YB, XB, YB, XB, YB. As you can see, we can conclude from this that the body force is distributed to the nodes in 3 equal parts. So I'm taking the area times the thickness, which is the volume, dividing it by 3. And these parts are going equally to the 3 nodes. Okay. So as we expected, so the body force distributed to the nodes in 3 equal parts.
One supposed to be 2 here, rotate here like 3. One supposed to be 2.
Yeah, I think that was the T. But, yeah. There is this is not a 2, is a T. And this is only 1/3.